we are seeing it every day around us. Every product is becoming a digital product. And when they become digital, they become cloud native. We talk a lot about platforms, architectures, but really what matters is our business. Scaling and growing the business is the main driver to any technological transformation. And so to grow the business, we focus on our products. We want to make existing users and customers happier. We want to be able to target new customers. And to do that, we become distributed. We enter new markets. We adopt the cloud. We stand on the shoulders of giants. The application teams are relying on us, the architects, to provide for them the best infrastructure possible for them to run the applications. Running a modern infrastructure is really like running a city. We, the architects, build the roads, the bridges, so that the application teams can focus on building the products and focus on the things that matter for the business, the users, the customers. But like running a city, we need to connect different places together. We need to enable the flow of traffic from one building to another building. We need electricity. We need police departments. We need security. We need routing. We need street lights. We need street signs. And the more buildings and the more people and the more cars are running in our city, the more complex the infrastructure becomes, so that we can run it in an organized way. There is really no other way around this. If we don't build this for our teams, then the teams will build this themselves in a very fragmented way. Or worse, they won't build this at all, harming the business. Sometimes, creating a modern infrastructure that can support our teams can be challenging, can be hard. It's all about connectivity. As we are decoupling and distributing our software, we are replacing the reliability of the CPU, the function calls, with the unreliability of the network. We are replacing the reliability of the CPU with the unreliability of the network. Some patterns, some techniques can help us with this, like service mesh. Likewise, we don't want to build our own infrastructure from scratch. We also don't want to build our network management from scratch. We want to be able to leverage technologies that can help us with this. And so instead of creating everything in our applications, we can outsource it to an out-of-process proxy that will run alongside every service and every instance of that service. By doing so, the developers can focus on the things that matter, the product, the business, the customers, while this new system takes care of everything else for them. And so the proxies that are running alongside every microservice really become the contact points for every connection. Service mesh, until now, has been a very hard topic and technique to implement in production for many of us. We learn a lot from our users, from our community. And we hear a lot from you that it's complicated, it's hard to implement, it's hard to deploy, it's too ambitional. That's why 20 days ago, we have released Kuma, our open source service mesh for every environment in the organization, universal. And today, we have released 0.2, a new version of Kuma. Kuma is a universal service mesh built on top of a very solid foundation, Envoy. Kuma implements the XDS API of Envoy so that the more services we have, the more sidecar proxies we deploy, the easier it is to manage the state of our infrastructure. Our teams are going to be running on multiple platforms. Some teams are going to be modern enough to run on modern Kubernetes and modern containers. But some other teams are going to be running on virtual machines. Some teams are going to be running on one cloud or multiple clouds. And chances are that the majority of the business today runs on one of those old platforms. Not in the new greenfield platforms, but the brownfield ones. The ones that we have to transition to these modern architectures. So Kuma has been built first and foremost to be platform agnostic. It can run across every environment, like Kong Gateway, and it provides an API abstraction which allows to deploy a service mesh on virtual machines as easily as deploying one on Kubernetes. It's multi-tenant since day one. We heard from you that deploying service mesh today implies very high operational costs. It doesn't have to be that way. That's why we built Kuma with multi-tenancy since day one, so that from one control plane, you can provision as many meshes as you want across all the environments, across all the teams in the organization. The service mesh, it's more valuable the bigger it is. The more services belong to the mesh, the more valuable that becomes. But pragmatically, different teams are going to be going at different speeds, different paces, because they have different products, different business requirements. So with Kuma, we don't have to force those teams to adopt service mesh all at once, but we can create independent service meshes for them whenever the timing is right. And because everything runs under one cluster of Kuma, we don't have to provision independent clusters for each team. We can keep everything in one place, and therefore, we can lower the operational costs of providing a mesh for your organization. But most importantly, and this is something that we've learned with Kong Gateway, no product can be adopted if they're not simple and easy to use. That's a key requirement. So the same simplicity we have delivered in the API management space with Kong Gateway back in 2015, that same simplicity we're going to be delivering in service mesh with Kuma. Kuma is very easy to use on top of Kubernetes and any other platform. It's available today. You can go online, you can download Kuma and try it yourself. Or you can go at the entrance in the Kong Lounge and talk with one of our engineers at the demo booths. Kuma provides on top of your infrastructure a few features, a few benefits that you don't have to worry about so that you can focus on maintaining and supporting your teams. It brings identity to your workloads. It brings permissions and segmentations for your traffic. It logs and observes everything that's happening within your infrastructure so that you can push it anywhere. You can push it into a remote server, into Elastic, into Logstash, into Splunk, into Datadog, whatever you're using today. And it supports the most adopted open source API gateway in the world, Kong Gateway, so that you can run them both together to enable connectivity within your infrastructure. And then for the traffic you want to open up outside of the data center, you can use Kong Gateway for that. One of the things that really makes no sense to me is how service mesh today, without Kuma, is being proposed as the last step of modernization. So we move to containers first, then we move to Kubernetes, massive transitions, by the way, and then after we've done that, we transition to service mesh. Service mesh is at the end, after we've already transitioned everything else. And that makes no sense. we want to have service mesh as the first step to our transformation. Because if you can implement identity, security, observability since day one, it's easier and a lower risk to decouple our monoliths into microservices. Service mesh is the first step. It's not the last step. With Kuma, we did not reinvent our networking layer. The same reason why you shouldn't reinvent your networking layer, that's the same reason why we shouldn't either. For Kuma, we're leveraging an open source project that has lots of momentum, that's a strong foundation for Kuma, Envoy. And who, better than Matt, can explain to you why Envoy is great? So I would like to invite Matt on stage here with me.
Thank you, everyone. Thanks for having me. Great to be here. So when I joined Lyft 4.5 years ago, Lyft's architecture probably looks very familiar to all of you. We're entirely cloud-based. Obviously, we have a bunch of mobile clients. We're using load balancers. At that time, we had a monolith written in PHP. We had some services in Python, and we had this beginning microservice architecture. And what was happening to us, which I think is what is probably happening to many of you, is that there was lots of problems. Because what people find when they move to a microservice architecture is that networking is very difficult, observability is very difficult, and developers ultimately, they don't understand what is going on. And what we found at Lyft is that they do not trust the microservice architecture. So we have this fundamental problem of we want people to decompose, we want them to move into different services, but then we just have this blocking point where the developers, they don't quite know how to actually understand what is going on and make further progress. So in comes Envoy. I have been working in this space for over 10 years. I've worked back at Amazon. I worked at Twitter before Lyft. So I've been working with network systems and proxies for quite some time. And I believe that our goal from an infrastructure provider perspective is to make the network transparent to applications. What I typically tell people is that all of us in the infrastructure space, we are ultimately overhead. We are doing a bunch of work, but organizations, they don't care about that work. They want to focus on their business logic. So every minute that a developer and most organizations is fighting with their infrastructure, whether that be networking or observability or Kubernetes or whatever, they are wasting time and they're not making money for that business. So we developed Envoy as a network proxy, and the goal of Envoy as a project was to effectively use it as an API gateway and as a service mesh proxy to make the network transparent to all of our application developers. So if you fast forward to Lyft today, about 4.5 years after we started the project, we now use Envoy almost everywhere. We use Envoy as our API gateway at the edge. We now run our services in Go. We have Python services. We've actually gotten rid of our monolith. And Envoy is a co-located sidecar that runs next to every service at our edge. And we use Envoy for all service-to-service communication. We use Envoy to talk to all of our back-end databases and our third-party providers. And the goal, again, is that we can move a bunch of this common logic around timeouts, retries, observability, load balancing, all these things into a common substrate. And it has been an incredibly powerful journey. So Envoy, we started it again 4.5 years ago. We open sourced Envoy about 2.5 years ago, and it has been the most incredible journey of my life and career. The uptake is more than I would have ever imagined. If you fast forward to today, Envoy is now in use by all major cloud providers. So many different companies have adopted Envoy to build their own internal service meshes. It's used as an API API gateway in many locations. We have tons of startups and other products that are using Envoy as a base to build vertical products. So it has been a truly astounding journey. So that begs the question: in such a short period of time, how has Envoy become so popular? And I think there's a couple of different reasons. Obviously, we focused a lot on performance. We understand that from a network proxy perspective, people are going to run those horse race benchmarks. We want to be competitive there. Envoy is a very reliable piece of software. I'm proud that to this day, even with the number of end users in very production critical environments, many of them run master. So we try to keep master at super high quality. Modern code base, we are a GitHub-driven organization, that uses CI, and we adhere to modern best practices. That's been very popular. But really, it comes down to operability. And I think because Envoy was created at Lyft, where myself and my small team rolled out Envoy ultimately to over 1,000 developers, and we had to operate it, and we were on call for it. There's a very strong focus in Envoy on observability, stats, metrics, logging, tracing, just generally making it easy to operate in these dynamic environments. Envoy is a very extensible piece of software. So from an open source perspective, we have scaled our open source community by allowing for all these different extension points. And today, the wide range of situations in which Envoy is used is truly incredible. It's really amazing. And now we come to our config API. This is really one of the killer features of Envoy. So historically, with most of our competitor proxies, the way that people would deploy complex configurations is they would fan out configuration files to every host. And for those of you in ops out there, I'm sure you've seen some pain of trying to get those config files out there and get them up to date and then reload your proxies. Envoy was built from the ground up, to work in a dynamic, eventually consistent, auto-scaling environment. So Envoy talks to a central control plane over what we call our XDS, or our Discovery Service APIs. And now we have many different APIs, but this has allowed, again, people to deploy out, relatively simple configuration files to their fleet of Envoys. And they all talk to a central configuration server. We now have a distributed system of Envoys, and that can be a service mesh or an API gateway or a middle proxy. So those are some of the technical reasons. But really, when I think about what has caused our astounding growth, it is you. It is the fact that we have built an incredible community. And along those lines, one of the interesting things about Envoy is that Envoy is a true end user, technology-first project. We are not open core. There is no primary business behind Envoy. And if you look at the ecosystem today, especially in the infrastructure software space, it's pretty rare that you find something like that. And this has been an incredibly powerful advantage for us. It means that we never refuse anyone's PR because it might cannibalize some business model. And it allows us to actually build an ecosystem on top. So I talked about extensibility and APIs. What we have seen is that we have all the cloud vendors, companies like Kong, all types of different people that are building solutions that actually compete against each other. And they build businesses on top of Envoy, but they all collaborate together in this open source. And I think this is just one of the best examples that we've seen of a true end user project where we allow companies to innovate, and we just have this incredible technology where we just focus on the technology and don't worry about the business. So in terms of Envoy, because of how widely it's now being deployed across numerous service mesh solutions, API gateway solutions within people's companies, I like to think of Envoy as a future platform, right? Because Envoy is a platform in which you can have extensibility, you have an API-driven system, you have configuration coming in, and you have data going out. And when you think about it, I think about it as the network operating system, right, for these cloud-native environments. And if you think about some of the things that can be built on top of that type of framework, where Envoy is seeing all of the data, can actually route all of that data, you can start building vertical solutions around security, observability, auditing, debugging, different types of management systems. And I think we've already started to see that, where you see other vendors that are starting to build Envoy integrations, which is super, super amazing to see. So again, just to recap, it has been an absolutely amazing journey with Envoy. It's been an incredible 4.5 years. I'm very excited to be here, very excited that Kong chose Envoy to build Kuma on. And again, with Envoy, we take quality and velocity very seriously. We want the system to be super extensible. My general philosophy from an open source perspective is I don't like to say no. I like to say, how can we make the right extension point that will make it so that you can do what you need to do. And I think as a project, we've rarely said no, but we haven't had to compromise the core integrity of the project itself. So again, just to recap, Envoy is a eventually consistent API-driven piece of software. This makes it really built from the ground up for these dynamic environments. No open core. We are a technology-first project, and we love companies like Kong, that want to build these differentiated solutions on top. And finally, again, thank you all as hopefully future Envoy users, and I will be around the conference if you have any questions. So thank you for having me. Thanks.
Thank you, Matt, and thank you for your open source contributions. Kuma is also open source, so you can go on our GitHub repository, you can download Kuma, you can contribute back to Kuma, and you can join our community forums. To summarize, every product becomes digital, and when they become digital, they require infrastructure that allows them to scale their business. They become cloud native. And when that happens, connectivity becomes the main roadblock to our success. Therefore, with Kuma, we want to fix and take care of connectivity as you focus into building the best infrastructure. Kuma joins the family of open source products that Kong is maintaining. Kong and Insomnia, among the others. And open source really has been the driver of all the transformations we're seeing in the industry today. If becoming digital is the most important thing that any organization can do, then we, the developers and the architects who are going to be implementing that transformation, become much more important in every organization. We are the drivers to modernization of not just the technology that runs within any business, but the business itself. Open source has always been part of our DNA, since even before Kong came out. And this would not have been possible, all of these open source projects would not have been possible without having a good and great community who participated and helped us improving our products. So we did this together, we built it together, and I would like to thank in particular 5 Kong champions for their contributions to Kong and to the products and to the broader community. So a round of applause to them, please. Open source would not be possible if we did not have self-service ecosystem where we, the developers, the architects, can go to try new software, to experiment with new techniques. Ecosystems have been a big part of what made open source so important today. When we look at the technologies that are driving this next era, technologies like Docker, like Kubernetes, they're all open source. And I would like to invite on stage Chris from CNCF to talk more about the importance of open source ecosystems.
Cool. Thank you, Marco. It's fantastic to be here. So, it's great to see companies like Kong invest in open source products and projects that they collaborate with their partners, clients, and other people in the wider community. But as someone who's been involved in open source for nearly 20 years across a variety of projects, I think a lot of us just underestimate how pervasive open source has become throughout our lives. Like if you have a phone, to the car you drive, to your TV at home, to maybe even that crazy refrigerator you bought with internet on it at home, all this stuff ships open source software, and we depend on it across all these different organizations, and to me it really speaks to the success of the open source development model. It's essentially the evidence is all around us how successful open source has been. So, my story is a little bit interesting, where a little over 4 years ago, I had the fun opportunity to help co-found an organization called the Cloud Native Computing Foundation. If you recall, Google was looking for a home for Kubernetes, which has become a fairly popular project, but more importantly, they were looking for a way to help educate the industry on cloud native techniques and programming. And if you kind of step back and look back where cloud native actually came from, it came from essentially the challenges that internet scale companies like Google, Twitter, Netflix, Facebook were dealing with as organizations. And given that they had all this crazy user growth and load, they had to actually come up with interesting techniques to deal with that. And I think as an industry, we're extremely fortunate that a lot of these companies decided to share these lessons learned through research papers, open source projects, and so on. And so the mission of CNCF is basically to take these lessons, whether they're projects or papers, curate them and help educate the wider industry. And if you kind of look at the last couple years especially, like Kubernetes has been like a crazy rocket ship that's basically, outside of the, Linux kernel, potentially the fastest growing open source project out there. As an organization, the CNCF has grown to be a lot more than Kubernetes, of course. We have 42 projects now, I believe, spanning 50,000 people contributing to this extremely large ecosystem. We have 500 members spanning, companies from Apple to Zendesk. We're very thankful that Kong is a gold member of CNCF and supports the organization. As you're aware from Marco and others, they announced a new open source project built on one of our top tier graduated projects in CNCF, Envoy. I think Matt kind of gave a fun little history of that project, but I kind of want to add some color to his presentation where, in CNCF, we kind of have this very data-driven approach of surveying and evaluating our projects and communities that we support. And today I'm happy to announce that we're releasing what we essentially call a project journey report. So essentially, which dictates and tells the story of how Envoy was founded, how it came to CNCF, the overall statistics involved in that project. It's quite amazing to see that, I think, maybe Matt was a little humble on stage, but, that project has grown so aggressively, basically, to kind of become the default data plane that people are building service meshes with and other interesting tools. There's nearly, 2,000 contributors spanning across 200 companies for that project. And if you kind of dive into the actual data, it's like a beautiful example of what happens when you build an open source project in a sustainable fashion. So if you look at kind of the data here, Envoy started from Lyft. They did all the heavy lifting and work, and over time they built a very good, neutral, sustainable community by involving other companies. And it's a good, healthy mix of not only vendors building products, but end users such as Pinterest and Slack contributing to this project, where even though Lyft and Matt still heavily contribute to Envoy and actually have grown their contributions over time, it only represents about a quarter of the total contributions now. They've done a great job diversifying that community, and I encourage all of you who are starting to experiment in the space to contribute and help sustain this project over time. And to kind of close things out, we're hosting a fairly large Kubernetes conference and Cloud Native conference next month in San Diego. We're expecting over 10,000 attendees, which makes it one of the largest open source conferences in the world. It's unfortunately a lot of staff issues to put on an event so large, but it's fun. But the important thing to highlight here is, as part of the event, we have these kind of co-located and kind of day zero events that map to specific topic themes or communities or member-focused things, and our friends at Kong are doing a modern service mesh and API management event, which, if aligns with your interests, you should definitely attend. But if you're new to Cloud Native and Kubernetes, or super experienced and want deep dive, this is the event you want to go to, and I hope I see many of you there next month in San Diego. So thank you, and I think I'll go hand it up back to Marco to kind of keep us going. So thanks.